Good evening everyone. My name is Siddhartha from second year CSCC section, and my PowerPoint presentation topic is graph coloring problem using backtracking, and my roll number is 234G1805F1, and the contents of the graph coloring problem are title, introduction, chromatic number, reason for learning, solving one example, applications, and finally conclusion. We will discuss one by one. And the title is graph coloring problem using backtracking. Introduction. So first of all, we have to know what is backtracking, then only we will discuss about the graph coloring problem. So backtracking is a technique in which if it is not possible to find a solution from a particular step, we backtrack to the previous step and continue solving using an alternate path. Graph coloring. Graph coloring problem is a concept in a graph theory that involves assigning colors to the vertices or sometimes edges of a graph in such a way that no two adjacent vertices have the same color. Graph coloring problem is also known as M coloring problem or chromatic number problem. Chromatic number. Minimum number of colors required to color the graph is called the chromatic number. So for example, the given graph is ABCD and the set of colors are red, green, blue, and one of the feasible solutions of the graph are red, green, red, green. So we can coloring the vertices of the given graph with any two of the colors. Then the chromatic number of the graph is 2. And the reason for learning. So why we have to learn this graph coloring problem or problem solving skills? The graph coloring problem enhance logical thinking and problem solving abilities. Applications in real world problems or graph coloring has numerous practical applications such as in scheduling, for example exams, tasks or job assignments, etc. And also the reason for learning of this graph coloring problem is research and innovation purpose. Solving one example. So for example, here is the one graph ABC, and the given set of colors are red, green, blue, and we can solve the given problem by constructing the state space tree using backtracking. Here is the state space tree, and the first part is considering red color for vertex A. Then we can, in part 2 we will consider the green color for vertex A, and part 3 we can consider the blue color for vertex A. So when we consider the red color for vertex A, we get two possible solutions. Similarly, so when we consider the green color for vertex A, we get two more possible solutions. Similarly, when we consider the blue color for vertex A, we can get another two possible solutions. So totally we get 6 feasible solutions for the given graph. So here the text of the problem. For considering the red color for vertex A, we get two feasible solutions. Similarly, if we consider the green color for vertex A, we also get two possible solutions, and if we consider the blue color for vertex A, we also get two possible solutions. Totally we get 2 plus 2 plus 2 is equals to 6 feasible solutions for the given graph. And the applications of the graph coloring problem are these are the two applications where we can use the graph coloring problem. One is scheduling problems, timetabling, used to schedule exams or classes when no two overlapping activities, for example exams with common students are assigned the time slot. And second application is map coloring, ensures that no two adjacent regions, for example countries or states sharing a border, have the same color, making it easy to distinguish between them. And the two more applications are, and third one is frequency assignment in wireless networks. Allocates different frequencies to nearby transmitters to avoid interference. This is essential in cellular networks, radio broadcasting, and other communication systems where overlapping frequencies would cause disruptions. And finally, the fourth application is puzzle and game solving. Ensures that no two adjacent regions, for example, countries or states sharing a border, have the same color, making it easy to distinguish between them. So this is the overall concept regarding to the graph coloring problem using backtracking. In conclusion, the graph coloring problem not only presents a rich area of theoretical study but also refers practical tools for solving a wide range of applied problems. So thank you for giving this opportunity to me. So I hope you will totally understand what is graph coloring problems, how we can solve a given problem, so why we have to learn the graph coloring problem and all. So thank you for giving this opportunity.